When we talk about climate change, the conversation almost always lands on one main culprit. But what if that's just the opening chapter of a much bigger story? Today, we're going to pull back the curtain and look at the whole complex web of things truly driving the changes we're all seeing.
And look, this is the big question, right? And hey, most of us feel like we already know the answer. But the reality? Well, it's a whole lot messier. And honestly, a lot more interesting than you might think.
Because for almost everybody, one thing just immediately pops into your head. Carbon dioxide, CO2. You know, the stuff that comes out of tailpipes and smokestacks. It's the villain of the story we all know.
But that simple story, while it's definitely not wrong, it's just not the whole story. The real picture looks a lot more like a tangled web, where a bunch of different factors are all pushing and pulling at the same time. And that's the web we're going to try to untangle today.
Okay, so let's start with the basics, the greenhouse gases. But we're going to look at them through a slightly different lens and uncover some truths that don't always make the headlines. First up, our old friend CO2. We all know the drill. It comes from burning fossil fuels for our power and cars, from chopping down forests that would normally soak it up, and even from farming. There's absolutely no doubt it's the poster child for climate change.
But here's our first untold truth. The impact of CO2 isn't just a simple case of more gas, more heat. It's not a straight line. Its real-world effect gets super complicated by things like how fast the oceans can absorb it and these powerful chain reactions called feedback loops. And we'll definitely get back to those later.
So let's move on to another huge player in this story, methane, or CH4. This gas comes from livestock, cow burps, rotting stuff in landfills, and when we extract natural gas. Now, it doesn't hang around in the atmosphere nearly as long as CO2, but while it's there, whoa, it packs a serious punch.
I mean, how much of a punch are we talking about? Well, get this. Over a 100-year period, a molecule of methane is a staggering 28 times more powerful at trapping heat than a molecule of CO2. That is some serious warming potential.
And here's something that often gets totally missed in the global conversation. We tend to think of global warming as this one big, even blanket, but methane's impact isn't like that. A big methane leak can create intense, regional warming hotspots, causing big local changes that get smoothed over in the global average. All right, the third gas we've got to put on the radar is nitrous oxide, N2O. This one's main source is agricultural fertilizers spread on fields, but it also seeps out from certain industrial factories and from burning things like wood and waste.
Now, here's what makes N2O so gnarly. It's a double whammy. Not only is it great at trapping heat, but it also chews away at the Earth's protective ozone layer. And the worst part, it's incredibly stubborn. It sticks around in the atmosphere for over 100 years, making it a long-term threat on two different fronts.
Okay, so we've got these gases that we're adding to the atmosphere, but our actions aren't happening in some sterile laboratory. They're being layered on top of a planet that has its own powerful natural rhythms. I mean, just look back at history. The climate has always been changing. We had things like the medieval warm period and later the Little Ice Age. And these events lined up pretty well with the sun getting more or less active. Now, this doesn't mean humans aren't responsible for today's warming. What it means is that our impact is being added on top of these natural cycles, throwing a huge new variable into an already complex system. And if you want to see just how complicated nature can be, look no further than a volcano. When a big one blows its top, it does two totally opposite things. It shoots out sulfur dioxide, which actually reflects sunlight and can cause a bit of short-term cooling. But at the same time, it's also pumping out CO2, which contributes to long-term warming. Talk about a mixed message. Okay, so now let's pivot back to us, to our own impact, because it goes way beyond just the stuff we're emitting. It's also about how we are physically reshaping the face of the planet itself.
This all comes down to a concept called albedo. It's a fancy word, but it's a really simple idea. It's just how reflective a surface is. Think about it.
A dark green forest has a low albedo, so it soaks up a ton of the sun's heat. Bright white snow and ice, they have a high albedo. They're like a mirror, reflecting that heat right back into space. So when we clear a forest, we're not just releasing the carbon in the trees, we're fundamentally changing how much energy that patch of Earth absorbs.
And it doesn't stop there. Our cities, with all their dark asphalt and concrete, create what are known as urban heat islands. They can be way hotter than the surrounding countryside. Massive cities can even change wind patterns and where it rains. And then you've got industrial aerosols, tiny pollutant particles floating in the air.
And here's where things get really counterintuitive. Some of that aerosol pollution actually helps to cool the planet by reflecting sunlight away. This creates a masking effect, hiding a portion of the warming that's already baked in. So, the crazy untold truth is that as we clean up our air, which of course is a great thing for our health, we could actually unmask that hidden warming and see a sudden jump in temperatures.
All of this brings us to what might be the most critical and maybe the most alarming piece of the whole puzzle, the domino effect. In science, they're called feedback loops. This is the point where the climate system itself can take over and start driving change all on its own.
Let's just walk through one of the most famous examples to see how this works, the ice albedo feedback loop. Okay, step 1. Warming temperatures melt some bright, reflective sea ice. Step 2. This exposes the dark ocean water underneath. Step 3. That dark water absorbs way more sunlight and heat. Step 4. The ocean gets warmer, which, you guessed it, melts even more ice. And the cycle just keeps feeding itself faster and faster.
And that's the truly crucial thing to understand here. These feedback loops mean that climate change isn't always a slow, gradual ramp. They can create tipping points, where a seemingly small change can suddenly trigger a rapid, runaway, and maybe even irreversible shift for the entire planet.
Phew! Okay, so let's just do a super quick recap of this complex machine. The real drivers go way beyond CO2. You've got other powerful gases like methane and nitrous oxide. You've got nature's own rhythm of solar cycles and volcanoes. You've got how we physically change the land through deforestation and building cities. You've got these hidden wildcards like aerosols. And powering it all, you have the engine of feedback loops.
So what's the big takeaway from all this? It's that climate change isn't just a simple pollution problem you can fix by plugging a smokestack. It is a deeply interconnected environmental, social, and economic challenge with a whole bunch of causes all firing at once.
Now, understanding all this complexity doesn't make the problem any less urgent. If anything, it makes it more so. But it forces us to think bigger and smarter about the solutions. So I'll just leave you with this question. Now that you can see the whole chessboard, all the different pieces in play, how does that change the game?